So with that, Cindy, please take it away.
Great. Thank you so much, Julie. I'm thrilled to be here today. As many of you may know, breast cancer rates are rising in women under the age of 40. And this is a trend that can't be explained by inherited genes. This makes Silent Spring's research on breast carcinogens all the more urgent and your support all the more critical. The scientists we're hearing from today and her work are supported by Silent Spring's Safer Chemicals program, which is funded in large part by donors like you. So thank you very much. Through the Safer Chemicals program, the Institute scientists are developing new methods for determining which, among the thousands of chemicals in use today, could increase breast cancer risk, so that we can prevent their use in products and create safer alternatives. Here with us today is Silent Spring research scientist and rising star, Dr. Jenny Kay, to talk about a new and exciting development in this program, hot off the press. As Julie mentioned, Dr. Kay studies how chemicals cause cancer, and she is the lead author on a groundbreaking paper published yesterday in the journal Environmental Health Perspectives, a high-impact journal of the National Institutes of Health. We're thrilled to let you know that news outlets, including Newsweek, Inside Climate News, and Environmental Health News, published articles yesterday highlighting this paper. Dr. Kay received her PhD in biological engineering at MIT and stayed for a postdoctoral fellowship in the Superfund Research Program, which recognized her with the Wetterhahn Outstanding Early Career Scientist Award. She joined Silent Spring in October 2022, and we're thrilled to have her with us today to share this exciting news and explain why it's important. So Jenny, before we launch into this study of yours, tell us first how you became interested in cancer research.
Thank you, Cynthia, for that introduction. Oh, does sound okay for everyone? Okay, great. I first became interested in cancer research really for the human-centric aspect of it. I wanted to devote my life to doing things that can help protect people from disease. And cancer, of course, is a disease that devastates a lot of lives. Something that really drove this passion home for me was my experience helping to start the MIT Superfund research program, where we studied a chemical that leached from a hazardous waste pit in the town of Wilmington, Massachusetts, into the town's drinking water supply. We worked with this community as part of the center, and something that I learned was that it was actually the parents in this town who started recognizing that kids were developing cancer at really high rates. And they were also the ones who identified this site as the likely exposure source. So it was the parents that pushed for, the state and eventually the EPA to recognize that a hazardous chemical that had leached into their drinking water was causing cancer in their children. And they had to struggle for decades to get that recognition. This issue, started becoming apparent in the 90s, and they only just got confirmation that this hazardous chemical was causing cancer in their kids a few years ago. So this was a really, moving and heartbreaking experience. We shouldn't have to wait for people to get sick to recognize which chemicals are dangerous. We need to do a better job of identifying those chemicals and preventing exposures so that we can prevent people from getting cancer in the first place. And that's something that I really love about my work at Silent Spring is we never forget about the people whose lives are affected by cancer. Everything that we do is motivated by this community-oriented focus on our research. So in addition to, sort of this emotional connection to cancer prevention, I just find cancer to be a really interesting disease. It's such a complex disease that's affected by so many biological processes, and I really enjoy taking things that seem chaotic and trying to make sense of them and break them down into understandable patterns. So something that Silent Spring has helped bring into my world of cancer research is that I used to be really focused on how DNA damage and DNA damage caused by chemical exposures can lead to cancer. And by turning my attention toward breast cancer, I'm gaining a greater appreciation for how hormones and how chemicals that disrupt our hormones can increase cancer risk. And that's sort of a piece of the puzzle that I didn't think about so much when I was studying cancer of the intestines and liver back in my PhD and postdoc.
So in this new study, which you just published, you identified more than 900 chemicals that could increase breast cancer risk. Did that surprise you?
Well, in some ways, what seems like a really large number of chemicals didn't surprise me. I knew that there are thousands of chemicals out there in the marketplace and in our environments that have toxic effects. What surprised me more is how few chemicals have actually been tested for the types of effects that we looked at. Some of the chemicals that we were able to identify, you might recognize, including chemicals in air pollution, chemicals used in consumer products like parabens, phthalates, and bisphenols, and also pesticides, including atrazine, which is used on many food crops, and also malathion, which is used on food crops as well as in lice treatments. So one thing that is important to remember about this study is that we identified hundreds of chemicals that have, concerning biological activities, and we are exposed to many of them on a regular basis. Some of these chemicals are very common, detected in, more than 95% of people who have been tested for them. And so this combination of exposures that we're exposed to just in our daily lives can have effects that really add up.
How did you go about finding these chemicals?
Well, this project really originated with our director of research, Ruth Ann Rudell. So I'm going to let her tell this story about how this project came about.
Hey, everybody, welcome and thank you for being here today. In the late 90s and early 2000s, as a toxicologist working for breast cancer activists who wanted to figure out how to prevent breast cancer, I wanted to know what chemicals cause mammary tumors in animal studies, because that's a good predictor of what might cause breast cancer. But there was no list of chemicals like that. So we made one. And we published in 2007, the first list. It had 216 chemicals that cause mammary tumors in animals. And that was big news, was on the front page of the LA Times and was covered in Science, and it was a very, a novel thing to do. What we've done now in the new paper is we've added to that we've updated the list of chemicals that cause the mammary tumors in rodents, but more importantly, we also added chemicals based on their activity in cell tests, their ability to make cells make more estrogen or make more progesterone or bind to the estrogen receptor. And we focused on those pathways because of course, the importance of those hormones as risk factors in breast cancer. So these pathways of estrogen and progesterone are well known to be very connected in breast cancer etiology and progression. Hormone replacement therapy with estrogen and progesterone increases risk. And some of you may know also about like aromatase inhibitors and tamoxifen. So these are drugs that are prescribed to women who've had breast cancer, and the aromatase inhibitors are given in order to stop the body from making estrogen, in order to prevent a recurrence. And tamoxifen blocks the estrogen receptor, again, blocking that pathway in order to prevent recurrence. So given how important those activities, those are for breast cancer, we found that we found data from a big screening test that EPA did. They did for estrogen receptor activity, and then another one for identifying chemicals that increase synthesis of estradiol and progesterone. And then we made a list, we added those to the list, and that altogether gives us the 900, and I still don't know the last two digits, 900 plus chemicals on the new list.
920. Yeah, so thanks, Ruth Ann, for that background. I mentioned before that I was surprised how many chemicals have never been tested for the types of effects that we looked at. So, despite tens of thousands of chemicals being currently used in commerce in the US today, less than 2,300 of them have been screened for the types of effects on hormones that we looked at to build this list. I think if EPA did a better job of screening chemicals for their effects on hormones, our list would actually be a lot longer.
So Jenny, what's one key finding from this research?
Well, I think one thing that our research really underscores is that chemicals that cause mammary tumors in rodents are more likely to be hormone disruptors compared with chemicals that don't cause mammary tumors. And that suggests to us that these chemicals that increase hormones are more likely to cause breast cancer as well. So we can start treating these chemicals that disrupt hormones as potential carcinogens and as hazardous chemicals without, having to wait for these time-consuming and very expensive cancer studies to start regulating them and start taking action. Our study, oh, I'm sorry.
No, go ahead. Go ahead. Sorry to interrupt.
So our study, also sort of challenges the traditional way that people think about chemicals that are carcinogens. Usually people think about carcinogens as being able to damage DNA, but this study provides compelling evidence that chemicals that alter hormones can also be carcinogenic.
So why is that definition important, that chemicals that can alter hormones are also carcinogens?
It's important because it affects how chemicals are regulated and how they're evaluated for safety. Currently, regulators at agencies like the Environmental Protection Agency are not really considering endocrine disruptors to be able to, act as carcinogens. As this is part of why we continue to be exposed to many of these breast cancer relevant chemicals, because they have not yet been phased out of things like products, furnishings, and building materials, because no one is required to, they haven't been restricted, so no one's required to take them out of products. The definition also affects how we do safety testing. So, since there are so many chemicals on the market, we need quick and effective tools to be able to predict whether chemicals cause cancer, like breast cancer. Right now, we mostly rely on animal studies to make those kinds of predictions. But to do an animal cancer study, it takes many years and millions of dollars to, do the test and then determine from those tests whether the chemical is likely to be a carcinogen in humans. And that's part of why so many chemicals haven't been tested for their ability to cause cancer. So our study provides a new approach to make those more predictions faster. If a chemical increases estrogen or progesterone, then that's a red flag and tells us that we need to be cautious. We should avoid this chemical and probably do further testing to understand its potential to cause cancer. We hope that this will be a really useful resource for regulators like the EPA. We hope that they'll use this as a guide to improve their chemical screening programs and take more proactive steps to reduce exposures by keeping chemicals out of products.
And I imagine it could take several years for regulators to use this list to limit these chemicals in our products. Are there any changes that are already underway?
Well, regulatory action does often take a while, but we hope that regulators will take this research and use it now because there is an urgent need to reverse this trend in increasing rates of breast cancer in young women. And we especially need to be reducing exposures for people at younger ages. People are most vulnerable to chemical exposures earlier in life during, development in the womb through childhood and adolescence. So it's important to reduce exposures for young people in particular, because those early life exposures can increase their risk of breast cancer later on. So to support, reduction of exposures at early stages of life, we're always keeping an eye on EPA activities to identify opportunities to provide scientific input so that we can help advance identification and regulation of chemicals that could increase breast cancer risk. So one example of that is that this fall, the EPA announced plans for how it plans to improve its screening of pesticides for their ability to disrupt hormones. So we are currently writing comments to the EPA about how they plan to structure this program, in particular highlighting the pesticides that we've identified as increasing estrogen and progesterone in our research.
Yeah, and I'll just build on that a little bit too. So our list of breast cancer relevant chemicals, it includes some that have like little or no regulatory scrutiny. Nobody's really paying attention to them. They're not really covered under laws. They're not there's not a lot happening with them, and that's so one of the things we're doing is just putting a little shining a light on those, and that can lead to regulatory attention. It can lead to manufacturers making decisions not to use those chemicals. It could lead to consumers and campaigns avoiding them. But then at the other end of the spectrum, our list has quite a few pesticides, and pesticides get a fair amount of attention. They have to be tested and approved by the EPA pesticide office in order to be used, and there's a fair amount of data that have to be generated by the companies in order to get those approvals. But in the EPA pesticide office has a reputation of being very close with the industry that it regulates, and we have been spending quite a bit of energy just trying to understand the scope of that closeness. I don't know if any of you read Sharon Lerner is a reporter. She's done a series of articles on EPA, but one in particular on corruption in the pesticide office. And so we 3 years ago, we published an article where we identified 28 pesticides that did cause mammary tumors, and for 19 of them, EPA had dismissed those tumors. And so this was just like, it's an indication of EPA's lack of seriousness or serious attention to breast cancer as a potential outcome of these exposures. Because if they care about breast cancer, they have to care about mammary tumors in the animal studies. And if they're dismissing them and trying to kind of wave their hands and explain that away, that's a real problem. So that's something that we're again trying to shine a light on with our scientific work, with regulatory comments, and we also partner with with NGOs that do different kinds of work, like litigation, like Earth Justice, or other organizations that can take our science and sort of use it. And then the new paper sort of extends that previous work on pesticides. Jenny really updated our review of the pesticides that had been approved, and there are 54 pesticides on the list that cause mammary tumors, and then there are another 191 pesticides on the list that have these endocrine activities that we consider relevant to breast cancer. Some of them are still active, some of them are canceled, and a new paper is going to be sort of providing a lot more information about which ones and expected and exposures and things like that. But so that's what we're doing.
Thank you, Ruth Ann. That's really, really important information and context for us. Appreciate that. Jenny, how is the Safer Chemicals program supporting research across the Institute?
Well, we have a lot of ways that we're trying to incorporate this new study into our ongoing research projects. So one of the projects that this recent publication is directly supporting is called Taking Stock. So in Taking Stock, we are following a group of Black women in California who are transitioning to embracing their natural hair and away from chemical treatments like straighteners. We are having them scan and log all of their products that they use, their personal care products, with our product logging app. And then that app will capture the ingredients that are in the products they're using and compare it to this new list that we just published. That'll allow us to see what types of chemicals people are being exposed to and through what products. This project is a partnership with Cleria, a group that has developed an app to help shoppers identify toxic-free products. So we hope that, this new collaboration will also get Cleria to include our new list of breast cancer relevant chemicals in their app that they've made publicly available.
That sounds really great. That's such important work for people to understand how to also reduce their own exposures. What's next for your research?
Well, Ruth Ann alluded to one thing that I'm working on right now, which is writing a paper that'll take this list of breast cancer relevant chemicals that we just published and really add information that'll help people translate it into health protective applications. So we'll be sharing information about how people are exposed to these chemicals, how much they're predicted to be exposed to on a regular basis, and also how these chemicals are currently regulated or if they're not regulated at the moment. So this will provide a way to prioritize which chemicals are the riskiest, both based on the biological activities that we discuss in this paper, as well as the chemicals that people are likely to be exposed to the most. We'll also identify the regulatory programs that could be used to help reduce exposures to these chemicals. Something else that I'm really excited about is that the paper that we just published and the one that I just described, the follow-up that we're working on, those projects are being done with publicly available data. But I'm really excited that I am starting a new project that I'll be doing at UMass Amherst, where I'll actually be going back to the lab to do some experiments. So like I mentioned earlier, this project and my work at Silent Spring has improved my appreciation for how endocrine disruptors facilitate the development of cancer. So since we know that DNA damage and hormone disruption are both important ways that chemicals can cause breast cancer, I'm now starting to do experiments where we'll track the early changes that are caused, that precede cancer development after exposures to a DNA damaging agent, an endocrine disruptor, and both chemicals together. And that'll help us to understand how DNA damage and hormone disruption cooperate to really start the path toward breast cancer development. These experiments will provide a set of early biomarkers or kind of telltale signs that researchers and regulators can look for when they test chemicals to understand their ability to cause breast cancer.
That's great. Really, really amazing work. So this has been a really interesting conversation, and I want to take a moment now to open it up to our other guests and invite folks to ask questions. If you have a question for Jenny, you can put it in the chat and it will go directly to Rachel, who will read it out loud. And I also invite you to watch in gallery view so we can see each other. Rachel, are there
And feel
any
free.
questions?
We do have some. We do have a couple, and I will bring those up. But feel free to also just do the raised hand icon or whatever, and somehow get our attention, and we can call on you as well. You don't have to put the question directly in here. This is now a conversation, so feel free to unmute yourselves and join the conversation. So as a consumer, can I use this list to live a healthier life and avoid exposure to these chemicals?
Well, the main purpose of this paper is to influence chemical policy. As consumers, we should not have to be responsible for understanding what chemicals are hazardous and knowing what products use them, figuring out for ourselves, how to protect ourselves. Really, it should be on regulators and manufacturers to ensure that the chemicals they use are safe before they put them into products that people will use in their lives. We are, that's part of why we produced this list to, provide a resource for regulators to see what chemicals are unsafe and provide a framework for identifying chemicals that are unsafe. People will be able to use the approach that we used here in developing this list to similarly identify other chemicals that could increase the risk of other types of diseases. So this is, a major step toward creating a world of safer chemicals for all, where we don't get exposed to hazardous chemicals because they're not allowed in our products in the first place. Of course, that being said, there are some things that we can all do to reduce hazardous exposures in our daily lives. Some of these include, trying to simplify your beauty routines. Silent Spring has shown that people who use fewer personal care products have lower levels of chemicals in their bodies. So this can be an effective way to reduce your exposures. We can also, try to work on avoiding pesticides, eating organic food rather than, food that is not organic, avoiding pesticides in our at homes, and also, avoiding products that are marketed as flame resistant, stain resistant, and antimicrobial. So to help, consumers protect themselves and avoid chemicals, Silent Spring has an app called Detox Me. So Detox Me includes the tips that I just listed, and many more that can be useful for people reducing hazardous exposures in their everyday lives. The list that we just published in this paper, reinforces that the tips that are already in Detox Me can be effective for reducing hazardous exposures. And with, support from donors and grants and through collaborations with groups like Cleria, we are actively working to improve our Detox Me app and build in more tips that can be used to reduce exposures to other chemicals on our list. We also have produced other types of informational materials. We have a handout card on breast cancer and the environment. And, Silent Spring is always trying to find ways to share information about how to reduce hazardous exposures with the public.
Yeah, adding to that, and we're excited that that our tips are now being disseminated at a high risk breast cancer clinic at the Brigham. So we've been working for years to get the clinicians to, I don't know, appreciate patients' interest in this topic and to provide relevant information. And so that's happening now, and that's really exciting. I was gonna also just emphasize that when consumers can play a role and with shopping, what we choose to buy and not buy, those choices really do shift the market, and manufacturers do respond. We've seen that with parabens, which we and others, started to sort of make a fuss about years ago, and they're actually they've been replaced by other antimicrobials, and that's another challenge and topic that we're working on, which is how to ensure safer substitutions. Our regulatory system right now doesn't facilitate that, but it will, I believe, and it should, and that's sort of why voting really matters also, and how we vote, because EPA doesn't have an instruction to do something, they can't do it. So it matters who our representatives are, how they feel about this. In terms of how the hand of the consumer has been effective, we've had some major wins with big box stores and some other chains like Dick's Sporting Goods and REI committing to phasing out PFAS in textiles. And this, in part came out of our own research we published showing PFAS in textiles marketed towards children, and also because of consumer pressure campaigns. But again, as consumers, we can't always know which ingredients to avoid, and so that's the reason that we're, really focusing on research that can inform better regulation and smarter formulation of products, so that we don't all have to be experts on every harmful ingredient in every product.
Great. So I also want to say that card that was mentioned, that is at the high risk breast cancer program at the Brigham, is also just available to people. So if you guys know of anyone who you think, I brought it to my radiologist and she has them in her waiting room too. So, feel free to talk to your doctors and ask if they'd be willing to display them. And you can email us to ask for see what it looks like. Alex, is it on the website, the actual card?
Yes, it's in the tips for healthier living section, but we can also provide a link to it in a follow-up email.
Yeah,
So
we'll be
everyone here
following up too.
can get that. Yep,
Yeah.
for sure.
I saw a
So-
couple of hands up on the screen.
Yeah, there are. We have some questions and we have some hands. I have a couple of questions ahead of you, Nancy, but hold on one sec. Let
Okay,
me-
thanks, Rachel.
Okay. So one question was, could you address other cancers that are caused by these chemicals? This is about breast cancer relevant chemicals, but these must also cause all sorts of other concerns. My interest is in endometrial and other gynecological cancers.
Yeah, that's a great question. There are several other types of cancers, probably many other types of cancers that are influenced by hormones. So, taking the example of endometrial cancer, there is very strong evidence that estrogen can increase endometrial cancer risk. So more than 500 chemicals on this list that we just published are ones that can increase estrogen production or bind to and activate the estrogen receptor. So those chemicals are also relevant for potentially increasing endometrial cancer risk. There are other types of cancers that we know about that are also influenced by hormones. So for example, cancer of the ovaries, uterus, and thyroid are all sensitive to estrogenic exposures and activities.
Great. So a couple of others. Okay, so sorry. You said the EPA pesticide office was dismissing mammary tumors so they could approve pesticides. Can you say more about why they're dismissing them?
Yeah, so we are definitely concerned that some of these we published about several themes that are, the rationale for why the EPA pesticides office tends to dismiss the induction of mammary tumors in cancer studies. And we are concerned that some of these decisions can be traced back to chemical pesticide manufacturers, because the studies that are cited by EPA in their cancer evaluations and the, published articles that they cite often have pesticide manufacturers as co-authors. And, as Ruth Ann mentioned, the EPA pesticides office is notorious for its revolving door between the EPA and industry and conflicts of interest between regulators and those who are regulated. So, for the themes that we discuss in this paper that we just published, there are a few major types of arguments that are made to dismiss those mammary tumors. One of those themes is that people will often dismiss chemicals or induction of mammary tumors at low doses of exposure to chemicals because they think that, if a chemical is really a carcinogen, then it would induce cancer at low doses and high doses. But that is actually not really supported by the evidence for hormone disrupting chemicals in particular. For endocrine disruptors, there is strong evidence that chemicals can have different effects at different doses. So low doses of a chemical may actually be better at inducing tumors compared to higher doses. Some other issues that we saw were that there are sometimes issues with the actual design of the study and the statistical choices that they make. So for example, the effects of a chemical in one study might be compared to a controlled group that was part of a different study many years ago and isn't really the best control to understand the effects of that chemical in the study that was performed. And one last thing that I'll mention is for a widely used class of pesticides that includes atrazine, atrazine being one of the biggest money-making pesticides on the market. The EPA and pesticide producers argue that the way those chemicals cause mammary tumors in rodents is not relevant to humans, but they really haven't proven that. So that's another, sort of way that we're thinking industry is probably playing a pretty big role in how the EPA decides whether chemicals are inducing mammary tumors or not from pesticides.
Great. All right. We have one more and then Nancy, is that okay? We have plenty of time at this point. Would fertility treatments be carcinogenic and thereby we'd be harming ourselves?
Well, I guess, for fertility treatments, prolonged exposure to hormonally active chemicals can potentially increase breast cancer risk. On the other hand, pregnancy at younger ages, in particular, can reduce breast cancer risk. So there's a trade-off when we're thinking about, pharmaceutical chemicals. The duration of exposure makes a difference. The window of exposure, so for example, during adulthood versus something during adulthood, people are generally less sensitive compared to at younger ages. And the activity of the chemical also makes a difference. So some chemicals that are on our list might be able to also do things that would reduce the potential risk of breast cancer. So for example, chemicals may increase estrogen but also block inflammation. So if there are sort of other activities that those chemicals have, then that could also impact whether they increase breast cancer risk. Ruth Ann, do you want to add anything there?
No.
No, I
Okay.
think that's good. Thanks.
All right. Go for it, Nancy.
As someone who does not have a science background, I know that this is a very complicated issue. In identifying the chemicals that are most at risk to the public, have you linked them to particular products, or would that be too complicated to do?
Well, it is a complicated question. There are some things that we can do. So for example, that collaboration with Cleria that I mentioned will actually be doing kind of what you just described, where we'll be incorporating this list of chemicals that we're concerned about into our Detox Me app and into Cleria's database. So then people will be able to scan their products and actually see, does this product contain any of the chemicals on this recently published list? So that'll be a tool for consumers. In the study that we're about to publish as a follow-up to this one of the things that we're doing is using EPA databases about chemicals that are used in products. So we'll provide some information about where these chemicals are found. For example, are the chemicals present in consumer products? Are they present in, dietary sources like in food and drink? So that'll be, another sort of layer of information that can help, this list be applied to both regulators identifying products that have chemicals of concern and also empowering consumers to choose products that don't have those chemicals.
Thank you.
Ruth Ann, do you want to add to that?
No, that was a great answer. Yeah.
Yeah, great. Thanks. Robin, hi.
Hi. Jenny, thank you so much. This is really fascinating. And you as well, Ruth Ann. It just listening, it seems to me it is virtually impossible to avoid everything that's out there. We have to live in this environment, and it's obviously it's not the healthiest environment. I did have to leave for a few minutes, so forgive me if this might have been touched upon, but I'm curious, what aside from myself and all of us as consumers and not being scientists, as Nancy said, when I look at a list of chemicals in a product, it sort of like I get, you know, blurry eyed. It's overwhelming. But what about how comfortable and safe can we feel with companies that say they are greener, like Seventh Generation or Method, even like some of the furniture companies, like I think Crate and Barrel for kids, they say that they're, sorry, the dog, greener. They try to, they're trying. I'm just wondering, how confident can we be? Are they actually safe or at least safer? Because I have two granddaughters, and my daughter, she models after me, and she's always trying to find products that are going to be safest for her family.
Yeah, so, it is like you said, extremely difficult for consumers to figure this out on their own, which is why we believe, consumers shouldn't have to. I like to think that companies that, advertise themselves as producing safer products are doing that in a good faith effort. Of course, just because a brand says that they don't use toxic chemicals, that does not mean that they don't use anything that could be harmful. Silent Spring has done some work really evaluating whether certain green certification programs do really capture all of the chemicals of concern that might be in products, and they don't always. But in the absence of really thorough information, I hope that those companies are at least doing some work to reduce the chemicals in their products.
I'd like to jump in with a more cheerful take on that. I think Robin's strategy is excellent. You can pick a retailer who has a red list, and you can pick manufacturers who've made commitments to red lists and use some of the product screening, third-party screening groups like Oecotex for textiles. I think one of the things I'm really proud of is that after we published our work on PFAS and textiles, Dr. Jenny O'Hagan went to those green certifiers and said, "Hey, we found this stuff in your products," and they were like, "Oh yeah, it's not on our red list," but they did make commitments to add it, and so we should be able to use those certifications in the future to avoid PFAS. You can also see this has become like a high profile issue on some of the companies' websites, like Patagonia is now extensively writing on their website about substitutes that they're taking PFAS out of their products. So I mean, yeah, it's not where we want to be, but things have improved enormously. And I do think these strategies of looking for retailers and manufacturers who've created significant red lists is an efficient way to go.
Yeah. I also, I just wanted to add to Julie's list, which is that REI has actually declared that they're not going to be selling any products with PFAS in it, which is huge. Like half of their stock has probably had PFAS in it. Sorry, Ruth Ann.
No,
Does
that's
that
fine.
mean they're not going to add another chemical to
But
replace?
PFAS, this is a good, can you explain this, Ruth Ann? PFAS is
I
a
think so.
class. Yeah.
This is a good example
Yeah.
of where because I think because of the history with some bad substitutions, environmental and public health groups have been very attentive with the PFAS chemicals to point out that it's a very big group. And even if we've studied a couple, and we have drinking water regulations for some and whatever, we really, we don't want any PFAS, because they all have this property of this carbon fluorine bonds, and enough of them that make it very, very persistent. The chemical's persistent. It doesn't sort of degrade, go back to sort of basic components that are useful for living things like carbon. And so with PFAS specifically, there is a like in the thing that Julie just talked about with where we talked to the certifier Oecotex that they do textiles. The point was that they had maybe on their list of like two PFAS that or 4 PFAS or 6 PFAS that you weren't allowed to have in the product, and we said no, you should make your criteria be no PFAS, not any kind of PFAS, so that you don't just get this substitution, and that worked. And the other, just the second point I just wanted to make is that this isn't static, so everything is always changing, and when we make this list, a lot of these chemicals are still in products, but this is the list. This is something manufacturers, consumers, environmental groups will react to. They'll react by saying, we shouldn't use this chemical, or we're going to regulate this chemical, or we're going to do a campaign about this chemical, or we're not going to sell products with this chemical. And then the landscape will shift, and those chemicals won't be so abundant anymore. And so, and that's happened, like it's happened in the past, where we got rid of DDT, PCBs, asbestos, lead. We're working our way out of lead. We've made a lot of this, mistakes over and over again, but and maybe we'll learn to do it a little bit better, this time.
I love something that we learned about this last year as a result of this a lot of this research for PFAS items that contain PFAS in California. You are no longer allowed to, this is a question I get from a lot of you awesome champions out there, that people will call me and send a picture of like a frying pan that says no PFOA, which is just one PFAS. And people will say, is this safe? And I have no idea what other PFAS chemicals could be in there. But now in California, they're saying you cannot put does not contain PFOA because it's misleading. People think that it doesn't have any PFAS when it says no PFOA. And now you're not allowed to. We hope a lot of California trends spread this way. So we're hoping that will happen here too. All right, I have a couple other questions. There's a follow-up. I'll do the follow-up question because I just got that. When we hear about
Cynthia had her hand up too. Yeah.
Yes, Cynthia
In case you
B.
didn't see.
Yeah.
Okay, great. Okay, hold on one quick sec. When we hear about companies like REI taking positive steps, it makes me wonder if anyone is considering taking on Whole Foods and the manufacturers of organic products for their use of plastics. Okay. Wouldn't that be nice? And does anybody want to take that? Jenny, I think it's your job to take on Whole Foods.
That is like not a science question. That is like an activism question. And some of our great partners are probably thinking about that. But our organization is focused on trying to create science that those groups can use for their work.
Yes. Yeah. And we can let you know if you're interested, email us and we'll let you know who some of those partners are. You can reach out to them. So Cynthia, where are you?
Here.
There you are. Hi.
Yeah, so just kind of as a follow-up to what Ruth Ann was just saying, I just have to say, as somebody who's been around for a while, and I'm sure Kathy Raghavan may be feeling the same thing, is it's just so heartening and encouraging, although frustrating that we're still doing this after all these years, just to see Jenny and this follow-up study to the seminal work from 2007. I was chair of Silent Spring, chair of the board several years ago. And in one annual retreat, we had an exercise where we went through over the years, the major milestones and progress that Silent Spring has made. And the 2007, the breast cancer list was certainly a seminal moment. And I think this could similarly be another seminal moment that could really change the game and raise the profile of these chemicals and get people paying attention to this. It's really exciting also to hear about, the oncologists or whoever was mentioned at the Brigham passing out, information about the connections between, or potential connections between chemicals and breast cancer, chemical exposure and breast cancer. So I just really wanted to say congratulations. And Jenny, I am so grateful you are on board and, picking up the torch here and carrying it forward because, frustratingly, like a lot of other things, this is a generational problem we're attacking and we need all generations focused on it. So thank you and congratulations. I'm really happy to see all of this.
Thank you so much for those kind words. It means a lot to me too to be able to do this kind of work. I'm grateful to Silent Spring for existing and employing me. And I'm so grateful to the donors who have made my work possible. So thank you for saying that, and thank you for, helping Silent Spring to have been an organization that's able to do this kind of work and has been doing this kind of work for so long.
Yes, I know. So Meg has her hand up. I also just want to say thank you to Cynthia for that. That was beautiful. And I agree. It's amazing to me the knowledge that is in this building. Like, it's like, ask them a question and boy, what do you get?
Yes.
Sorry, go ahead, Meg. Thank you.
Hi, lovely to see you all today. I just wanted to pipe in about the organic regulations because this is really a big thorn in my side, being connected with a lot of organic companies over many years now. Back when the organic regulations were created, late 1990s, early 2000s, there was no consciousness about plastics in food and all of the toxic chemicals that we are exposed to through packaging. So there are no regulations. And now that the organic seal is a product or owned by the USDA, the chances, even with the advisory board that advises the USDA on organic regs, there is virtually no chance that this is going to, I hate to be a pessimist, but to get it through the USDA is going to be nearly impossible to make those kind of changes. So I would encourage all of you with any consumer reach. I mean, this is where we have to vote with our dollars, to really ask people to really ask those questions, write organic companies saying, what are you doing about your packaging? What are you doing about are you paying attention to your suppliers and, everything from plasticizers, in the tubing that, that is in milking machines. I mean, these are the kinds of things we have to bring up directly with manufacturers to make any kind, and really vote with our dollar on this one, because I do not think we're going to see, unfortunately, any change on a regulatory level because it is now USDA property. So I just wanted to mention that. Also, I just want to say too, being connected with a lot of organic companies, there is a profound level of ignorance about this topic, even at the companies themselves. They're very focused on sourcing organic ingredients, which is fantastic. But there's very little actually indigenous knowledge in these companies about the way that they're contributing to sort of the toxic stream through packaging. So that's another way that this group can be of service.
Thanks for that. That's all very helpful.
Yeah, thank you. So I have another question. Oh, Robin, looks like you have another question. Go ahead, Rob.
Okay, thank you. I just wanted to piggyback on what Meg just said about the ignorance out there. I am astounded that within the past several years that now Lululemon is adding like these odor proof something in their clothing. You know, as my mother used to say, you know, you're not supposed to smell good at certain times, but you know, we don't need the chemicals. And I asked them about it. They said they use like a silver thread or something. And then I tried to research it to see if it was safe. And it's almost impossible to find leggings or t-shirts or anything without these chemicals now. I think even in the bras. So, I mean, as a consumer, is that another avenue I could explore, like writing a letter to Lulu and say, because now I won't buy their stuff, but that doesn't mean that the other companies aren't sort of following up on this because they think this is what the consumer wants. And again, that's just pure ignorance. Here we've been working, Silent Spring has been working for years and years and years to pull out the chemicals. And here's a company that so many women buy products from that are adding chemicals. It's just mind-boggling.
Yep. It really is. It's very frustrating. I'm considering just moving to the mountains with nobody around. So um so I have a question that we're batting around here behind the scenes because it seems like an interesting question, but we're not sure we understand the whole thing. So I'm just going to ask it, and then Ruth Ann and Jenny might want a little bit of clarification. I'm wondering if the research on these 900 or so chemicals includes any analysis of where we are likely to become exposed. For example, if the chemical is often found in pesticides, used in farming or in hair care products, and then consider the size of the molecules of those chemicals compared to the exposure method. So Ruth Ann and
Well,
Jenny.
I'm just thinking that the first part of that question is sort of where these chemicals come from and how might we be exposed, how much exposure is there? And that is coming in the second paper, which I've just decided we need to set a deadline for ourselves to submit. And then I'm not sure what's meant by the second part about the size of the molecules. But if anybody wants to sort of clarify in case we didn't understand, yeah.
Joe, do you want to?
Yeah, I'm wondering, I mean, if something like in a hair care product, which you're studying in California, I would think that the size of the molecules of those chemicals compared to the size of the receptors in your skin has something to do with how much exposure you actually get. Same thing with stuff that's used in pesticides. Does that mean that the minute we eat those foods, we're being exposed?
I think that question is about the variety of routes of exposure and how the different substances will behave in different exposure scenarios. So Joe mentioned like dermal exposure, if you put something like a lotion on your skin.
How much?
Uh-oh, I think we may have lost Ruth Ann.
Oh,
Hopefully she'll be back in a second. But
I can try to pick up where she was probably going with that if you'd like.
Sure.
And Ruth Ann can jump in if she wants to add more, you know, provide a different perspective. But so the like levels of exposures that we actually get from these chemicals depends on, how our bodies are set up to respond to them. So some chemicals are, broken down very quickly in our bodies into components that might be more or less toxic than the original chemical itself. And some chemicals will be absorbed easily through skin, whereas some chemicals would not be able to be absorbed through skin. So every chemical is kind of different in those properties. Of, how our body is actually able to absorb and then deal with the chemical once it's been absorbed. And there's a whole field of science that is dedicated to making those predictions about, if you have an exposure of this level, then how much does that actually translate to activity in the body? We are starting to do a little bit of research that would incorporate that kind of analysis for some of the chemicals that we identified as increasing estrogen. But it's complicated, I think, is one major point.
Well, that's a great question, actually, Joe, and that is what we're trying to do is, we have actually a new research assistant with a applied math and biology training, and they are working with us to convert, like EPA actually for all of these chemicals, or almost all of them, EPA has made sort of like an estimate of how much the general population in the US is exposed to. That's going to be in the second paper. That's about intake, like how much are you exposed to? And then we're going to be taking that information and using models to predict expected blood levels for each of the chemicals in the US population. And then we're going to be using information about how strong was the chemical, how easy was it for the chemical to cause the effect? Did it cause a big effect on estrogen levels, a small effect on estrogen levels? Did it take a lot of it to increase estrogen, or did just a little bit increase estrogen? So we'll be pulling all of that information together. The goal is, which are the chemicals that are having the biggest effect in everybody, So that's where we're headed.
And Ruth Ann was talking about another way in which we're trying to get the fast, inexpensive information about how to evaluate risk. So Jenny Kay's work that she talked about today was about using models in laboratory experiments, but Ruth Ann has now added this computational dimension where we take the data that's out there and make it useful for understanding risk.
And
Meg, it looked like, oh, sorry.
We also published a paper about a year ago where, we have the chemicals that were actually tested in the cells to see if they increase estrogen and progesterone. In that paper, Alex Burrell, who's now back at NIH, but was with us for a while, built a model using chemical structure to predict if a chemical was likely to increase estrogen or progesterone. Did it have a structure similar to the structures of the chemicals that did that? And so that's sort of another way of extending the work, using computational tools to try to make it easier to flag chemicals that have characteristics that are likely to be promoting breast cancer.
All right, I have one more question in case anyone else has anything to add to this conversation. So the one more question is, could we hear more about the relationship between chemicals and thyroid cancer? I'm a 20-year thyroid cancer survivor and co-facilitator of a thyroid cancer support group.
To be perfectly honest, I am not a thyroid cancer expert. So if anyone has, more biological insight to the processes of thyroid cancer, I will let you take this question.
I haven't, I think that there's two things. I've been following chemicals that affect the thyroid, not necessarily as carcinogens or as causing thyroid cancer, but there are a lot of chemicals in commercial use, some that have been taken out, but have been very abundant in the past, some that are still around, that affect thyroid. And I know that many people, especially women, have take thyroid supplements. And I know that also thyroid thyroid hormone levels, if they're not high enough, they have a substantial effect on IQ of children. And that is what the PBDE flame retardants, which were phased out in the early 2000s, that's what they did. And that was our work too, that actually identified not the IQ effects of them, but how abundant the exposures were and why the exposures were high, which was because this California law was requiring lots of this flame retardant in foam of furniture. So there are many, so PCBs, PBDEs, and there are many other chemicals that do target thyroid. But what I don't have good information on is the connection to the cancer specifically. I also was at a symposium recently, and I was very interested to hear a talk. This was from somebody at the National Cancer Institute, but what she was saying is that there was actually also a sort of, I don't know, an epidemic of overdiagnosis of thyroid cancer. So things were being diagnosed as thyroid cancer that weren't going to actually progress. And so quite a few people were caught in that. I don't know even to what degree it's resolved at this point, and maybe somebody else on the call knows more about that.
Okay. So I just want to say before I pass it back to Cynthia to close us out, that we do this funding, all of Jenny Kay's time at Silent Spring Institute is supported by the Safer Chemicals program, of which we have a couple of donors too in the room today. And we are so, so grateful for your support, as well as everybody who supports us in the general fund as well. Barbara. Oops, you have to unmute yourself. Sorry. Oh, there you go.
Hi, I'm not a scientist, but I just wanted to say something. I know that there's positive inflammation in our bodies, and that's a good thing. But there's also negative inflammation in our body. And I was wondering, as individuals, if maybe some sort of venue where people, I don't know how to say it, but like each person has an understanding of that, and that maybe that would help with all that you're doing, because then people would know what to do, like younger people. Am I making any sense? Did you hear me?
Mm.
It's in other words.
I heard you.
Okay.
Ruth Ann, do you have any thoughts?
What was the word that you used? Positive and negative?
Inflammation in your body.
Inflammation?
So that in other words, the positive is a good thing, that the negative is a bad thing. And I just wondered if there was any correlation, because I've been studying a little bit about negative inflammation in the body. And I've been doing a lot of little things that I hadn't done before. And it's just a thought. It's not It's not a suggestion, it's a thought. And I think that, that kind of gets people, especially younger people, on a path of what you're trying to do here as far as, chemicals and quality and, keeping your body in a good place. Anyway, that's all I wanted to say. Thank you.
I can maybe add to this, talk about positive and negative inflammation. I actually used to study inflammation. And so inflammation is necessary to deal with, certain types of exposures. So things like viruses and bacterial infections, you need inflammation to be able to clear those. And you also sometimes need inflammatory processes. You need inflammation to clear out damaged cells to prevent them from potentially becoming cancerous. But what you don't want is inflammation for no good reason. And that's definitely a concern. So, if there's inflammation going on that is not serving a specific purpose to help protect you, then that inflammation is not going, that is bad. That is not going to help you live a healthy life. So in general, taking efforts to reduce inflammation that is not serving a specific purpose, like, eating foods with antioxidants and things like that, will help you live a healthier life. And that's sort of general information that can, support all types of wellness, reduce breast cancer risk, other types of cancers, all sorts of things.
Thank you.
So as I was saying, I really appreciate everyone for being here. And I just wanted to say thank you for coming, and I will pass it on to Cynthia.
And I want to say thank you as well. Thank you to Jenny and Ruth Ann and all of you. It's been a really, really terrific discussion. Wonderful information, wonderful major breakthroughs that Silent Spring is working in as always. And if you have any additional questions, please feel free to reach out to Rachel and she'll follow up with you. So with that, thanks again for attending today's Science Cafe and have a great rest of your day.